Good morning, everybody. Today I want to go over this blood type worksheet, which I've assigned for this week. Blood types are, these are the same type of Punnett square problems we did last chapter, except there's going to be three alleles. There's two capital I's, one that's IA and one that's IB. They are both dominant. They're co-dominant. So if you have one of each allele, you are blood type AB because you produce both the A antigen and the B antigen. The lowercase I is recessive. And if you have two recessive alleles, then you have blood type O. Okay, so there's a chart at the top of the paper that kind of goes over all the blood types and their options. Question number one, just kind of make sure you understand them before you do the rest of the assignment. If you can't do number one or you don't understand it, you will not understand any problem further down. So make sure you understand these ones before you move on. Okay, so the first one says, what is the genotype of somebody that's homozygous with a B allele? Okay, so homozygous means two of the same, and the B allele is IB. So this person would be IB, IB. Okay, the second one says heterozygous for the A allele. Okay, so heterozygous means two different alleles. So in this case, we have the IA allele, but because they're heterozygous, they also have a lowercase I, which is the recessive allele. Okay, next one says blood type O. So that's the phenotype, the actual blood type. O is recessive, so the only way to be blood type O is to have two of the lowercase i's. Okay, blood type AB. This is the scenario where you have both of the dominant alleles. So your genotype would be IA, IB. Okay, over here it says blood type A. There's two ways to have blood type A. Okay, the two are the person could have two of the dominant A alleles, so IA, IA, or you could have IA lowercase I, so you could be heterozygous. Okay, same thing for B. You could either be IB, IB, or you could be IB lowercase I. So there's two options to have blood type A and blood type B. That's important because you're going to see in later problems on, it will say blood type A, but you don't know which one it is unless they give you more information. Okay, and then the last one says blood type A with a parent that has blood type O. Okay, so because they're blood type A, we automatically know they have the allele IA. Now, it says their parent is blood type O. Okay, so somebody who's blood type O has two lowercase i's. So one of those two alleles has to be given to the daughter or son, whatever, the kid. So this person has to have the genotype IA lowercase I. It's the only option. They can't have two IAs because the parent would have blood type A then. Okay, I'm going to erase that one. Just make sure you guys keep those ones in mind as you do the rest of the problems. I'm going to go on to number 3, which will be a Punnett square problem. So it says, draw a Punnett square showing the possible blood types that are produced from an offspring produced by a type O mother and a type AB father. Okay, so draw a normal Punnett square. Okay, so one parent is blood type O. So there are two lowercase i's, and the other parent is blood type AB. So their genotype is IA, IB. Okay, so now just fill in the Punnett square like normal. IAI, IAI, IBI, IBI. Okay, and then lastly, just figure out the phenotypic ratio. 50% of the kids would have blood type A, and 50% will have blood type B. Okay, so they're the normal just Punnett squares like we did last chapter. Okay, I'm going to erase this. I got to go kind of quick because, again, my videos can only be 15 minutes long. Okay, I'll do number 5. Number 5 says, two parents think their baby was switched to the hospital. It's 1968, so we can't do any DNA fingerprinting. So it says the mother has blood type O. So 5A says the mother's genotype. So we know her genotype is II, lowercase i's. The father, so sorry, this is the mother. And then father, it says he has blood type AB. So we know he is IA, IB. Okay, it says create a Punnett square and determine all the possible blood types of the kid. The baby has blood type B. So the question is, can we determine if he was switched at birth? Okay, so let's draw a Punnett square. In fact, this is the exact same Punnett square we just did in problem 3. So the exact same thing. So you can literally just copy it from number 3. Okay, so it says the baby has blood type B. Can we conclude that the baby was switched at birth? So basically, is it possible for these two parents to have a child with blood type B? Yeah, they have a 50% chance to have a kid with blood type B. So no, the answer is we can't conclude. We can't tell for sure the baby was switched at birth using just blood types. Okay, it is possible that this baby is theirs based on blood types. Okay, how about we do number 7? I'm just kind of switching around. You guys can do the other ones. Okay, number 7, it says, based on the information table below, which man could not be the father of baby Bill? So they give you the mother's blood type, the baby's blood type, and then three men. Basically, which one cannot be the father? So 2 of them have the possibility to be the father, 1 does not. Okay, so it says the mother's blood type A. So the mother, we know, is either IA, or IAI, and Bill, which is the kid, is blood type B. So we know he's either IB, or IBI. We don't know which one. They haven't given us any further information. Okay, so let's look at the 3 males. George is blood type AB. Okay, so can you figure out a way that George could produce a baby with blood type B? So think about it. George has the genotype IA and IB. So he has the B allele, so he could pass it on to the kid. So George could be the father. Okay, I'm going to skip down to the cable guy. Cable guy is also has blood type B. So he has the IB allele, so he could also be the father. But the waiter is only blood type A. So if the blood type of the waiter's A and the mother's A, there's no B allele there. There's no way they could have a kid that has blood type B. And let's prove it. It says it wants a Punnett square. Okay, so the mother's blood type A. It doesn't matter which one of these I choose. It won't matter because it's impossible to have a kid. The waiter is also blood type A. So it doesn't matter. I'll choose this one, the heterozygous version. It doesn't matter. Neither one has a blood type or a genotype IB. So if you fill this in, you will see, it should be very apparent, there's no chance to have a kid with blood type B because neither parent has the IB allele. So the answer to this question is the waiter. The waiter cannot be the father. Okay, you guys can try the rest of them on the first 2 pages. I did want to very quickly do the giant pedigree on the 3rd page. Okay, I'm going to have to go quickly again because my videos can only be 15 minutes and I have 7 minutes left to do this in. So it wants you to create a giant pedigree. I'll try to squeeze this on my board. Okay, it says Maureen decides to do a giant pedigree of her family's history, starting with her great-grandmother, Catherine. Okay, so at the top, I'm going to put a woman. I'm just going to put Kath for short. So it says, here's what Maureen found out. Maureen's great-grandmother, Catherine, has blood type A. I'm going to try to write the symbols in there. So she has blood type A. So I know she carries the IA allele. I'm going to try to move this closer just to make it as big as possible. I don't know what her second allele is yet. I'll come back to that. It says, moving on, it says Catherine and her husband John. So Catherine is married to John. They had 4 children, 2 sons and 2 daughters. So 2 sons, 2 daughters. So I'm going to come over here. Son, daughter, daughter. Okay, they had 4 children. 2 sons, Michael. I'm just going to write Mike. Mike has blood type AB. So I'm going to write IA, IB. I know his genotype. That's the only way it could be. David has blood type O. He also, we know his genotype is II. Okay, a daughter, Jessica. I'm going to write Jess. Jess has blood type O also. So II. And another daughter, Jennifer. I'm just going to write Jen. with blood type A. Okay, so I know she has the IA allele. I'm not going to fill in that second allele yet. I will come back to that. Okay, now based on this information, I can figure out what the Catherine's other allele is. So look, David and Jess both have two lowercase i's, right? One of them has to come from John, and one of them has to come from Catherine. So I can fill in the second allele for Catherine and one of the alleles for John. Now I can go even further. Look at Mike. Mike has the IB allele. We know it didn't come from Catherine, so we know it came from John. So John has blood type B. He's heterozygous, IBI. Okay, also Jen, we know she's blood type A. So I know she's doesn't have this allele. So John had to give her either the IB or the lowercase I. Since she's blood type A, I know he had to have given her the lowercase I. Okay, so you got to go and do a little bit of deduction here. Okay, moving on. It says Jessica never married. Her sister Jennifer did get married and had 3 sons. So was that Jennifer? Yeah, Jennifer got married and had 3 sons. One had blood type A, so IA. One with blood type AB. Here, I'll try to make these bigger. So this one is IA, IB, and one with blood type O. So II. They don't give us any names for these ones. Okay, so now I can figure out what the parents are, or the dad, the father is here. They don't give us a name for him. We know this IB allele had to have come from Dad because it didn't come from Jennifer. Also, we know that since this person has 2 I's, lowercase i's, one of them had to have come from the father. And lastly, we know this person has blood type A, so we know the father had to have given the lowercase I, because if he gave the IB, that person would have been blood type AB. Okay, moving on. Both of Catherine's sons get married. So Mike gets married. David gets married. Mike marries a woman with blood type O. Okay, so Mike's wife has blood type O. They have 2 daughters. Anna and Leanne. Anna has blood type A, so IA. And Leanne has blood type B, IB. Okay, now I know their second allele because look at their mother. Their mother has only 2 lowercase i's. So both of these people have to be heterozygous. Okay, I only have 2 minutes left, so I'm going to do this quick. David marries a woman with blood type A, and they have 3 children, a daughter, a son, and a son. So a daughter, son, and a son. Fran and Albert have blood type A. So Fran, Albert have blood type A, so IA. I know they also have to have a lowercase I because David has 2 lowercase i's. And they have a son, Matthew. I'm just going to write an M with blood type O, so he is II. Okay, lastly, Matthew marries Janine. So I'm just going to put a J there. And they have a daughter, Maureen. She's the one who is doing the project. Okay, Maureen knows that her parents both have the same blood type. So that means Janine also has to be recessive, II, which automatically means Maureen only has one option. She is II. So Maureen is blood type O. Okay, so I know that was a long problem. You'll do a little bit of deduction there. You had to figure out some people's second alleles, looking at their fathers or mothers or their children potentially. But hopefully this made sense to you. Please draw this out on a separate sheet of paper or print out the paper and turn this in. For the problems on here that I didn't do, you have to do Punnett squares. Please show me Punnett squares. Those of you trying to do this on Google Docs, it's not very good. Just handwrite all this stuff on a blank piece of paper, take a picture of it, turn it in. Let me know if you guys have any questions.